Okay, guys, so I kind of went out of order a little bit, but that's okay. And the next definition that we're going to talk about is this thing called an internal standard. So, internal standard is abbreviated as an IS. That is the abbreviation that we use in the quality control area and in the laboratory setting. So, if I read this definition of what an internal standard is, it says a pure analyte or analytes added to a sample, extract, or standard solution in known amounts and used to measure the relative responses of other method analytes and surrogates that are components of the same sample or solution. The internal standard must be an analyte that is not a sample component. Okay, blah, 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 blah. I mean, that's what I just kind of read, right? So again, I think it's my job to flesh out this definition of an internal standard a little bit better, because if you're not very careful, you're going to look at internal standards and surrogates and you're going to be like, well, what's the difference, right? I mean, a pure analyte is added to a sample, and the surrogate says a pure analyte is added to a sample. And then it says, we're going to measure the responses. And then the surrogate's going to be, we're going to measure those responses. So, why on earth is there something a little bit different here? And here's the catch. All right, so we're going to talk about internal standards, and we are going to compare this against the surrogates, because this is often something that is a problem with some people that work in a lab if no one's ever had this discussion with them before. All right, so let's talk with internal standards first, and then we'll do the comparison. All right, so for the internal standards, we're again, number one, going to pick something that is unlikely found in a sample. So this is something, yet again, that we're going to have to pick and choose, and we're going to have to add it to the sample because it's probably not going to be there. We're going to add a certain amount. We want to make sure it's the same thing over and over and over. We want to make sure our numbers match accordingly. So internal standards are unlikely found right off, just like surrogates are, right? So ding ding, okay, they're the same. Internal standards and surrogates should not be found in a sample, period. That's what goes on here, all right? Number two, so that's number one. All right, so number two, we're going to add a known amount or a known concentration to the samples. Okay, ding ding. This is exactly the same as the surrogate so far, okay? Because the surrogate, we picked something that was unlikely found, and in the surrogate, we added a known amount to that sample, and here with the internal standards, we're also adding a known amount to that sample as well. But the difference, the difference is that it not only goes to samples, but it also goes to standards, and it actually will be applied to everything for the most part. So this goes above and beyond the sample processing. So the surrogate's role is to make sure that the lab handler, the lab worker, is processing samples properly, is measuring out samples the proper way, the data analysis matches what it should be expected. Okay, that is the purpose of a surrogate. The internal standard has a different role. So yes, it is like the surrogate, meaning it's unlikely found. And yes, it is added a known concentration just like the surrogate, and we should be able to see a number. But the difference is that internal standards are added to everything that we process. Our samples, our standards, and everything else in between. All right. Now, you might not know exactly what standards are right now, but I'll get into that in just a minute. But it's everything, period, point blank. That is one of the major differences between internal standards, IS, and surrogates, or SAs. All right, so number three, what happens is that we hope that it matches expected values. So once we get the data and once we get the analysis, we process these numbers, we get values, we know what's supposed to be there, and we hope that it matches the expected forms of them, right? But meaning here, because it is the same amount that gets added to everything. We are looking for consistency here. That is what we're after. Well, consistency of what, right? I mean, if I'm adding it to the samples, if I'm adding it to the standards, if I'm adding it to everything across the board, well, we want to make sure these numbers are staying consistent report after report after report after report. What exactly are we testing? Well, okay, number 4 is that the internal standards will actually end up testing the instrumentation most of the time. All right. And the reason that I say this is because the instruments have a syringe, the instruments have auto injectors, the instruments will take over and will inject sample after sample after sample for you, so you don't have to be there with it. And the internal standards are double checking the equipment. We want to know, is the equipment injecting the same amount every single time? Because there's going to be some fluctuation. There's variation there, right? Not everything is going to be perfect. Not everything is going to match. But we hope that it's in the same arena. We hope that it's in the same ballpark, because if not, then we have to correct for those issues. What if, at a certain point in time, the machine injects not enough sample? Do we have to completely invalidate that data point and inject that sample again? Well, what if you didn't have that opportunity, right? What if you were in the laboratory and you were injecting samples and you were processing these things, and they only gave you a little bitty smidge of sample to inject into the machine, and you had one shot, and that was it? Okay, well, I don't have the opportunity to go back and reprocess a sample and re-inject, right? So the internal standards will allow us a way to go in and correct for those mistakes that are due to the instrumentation errors that could show up in this entire process. That is what this thing is all about. All right. So internal standards, unlikely found, like a surrogate. You add a known amount, like a surrogate, but you add it to everything across the board, which means that this addition does not have to be in the beginning. That is one of the things with the surrogates. The surrogates, you typically go in the very beginning of the process before any of the sample processing takes place. However, internal standards do not have to be in the beginning, and actually they, for the most part, happen at the very last stage of the processing. So once I have all my samples processed, once I have all my standards made, once I have everything ready and it's ready to be kind of entered into a machine and ran for us, well, the issue here is that at the very last step, I begin to add internal standards, most of the time toward the end, right? And then toward the end, no more sample processing is taking place. That's not the purpose of internal standards. That's the purpose of the surrogate. Okay, the internal standard is to check the machines, not the lab process. So closer to the machine is going to be better. Closer to when we put the samples into the instrument and close the door, the closer the internal standard is added, the more likely it is to give us a better picture of what this thing is going to be doing. So if I go back to this method document and I reread this definition, internal standard, IS, is a pure analyte added to the sample, extract, or standard in known amounts, and used to measure the responses of other method analytes and surrogates that are components of the same sample or solution. The internal standard must be an analyte that is not a sample component. So at no point does it really tell you instrument. At no point does it tell you equipment, right? But that's exactly kind of what this is doing. It's just when you do the process the first time, you go through the motions, you'll be like, oh yeah, well, why didn't they tell us that? Well, that's kind of the thing here with the method. It doesn't. And it's one of the reasons that people have just a misconception of what goes on. So here I'm going to say, all right, we're going to take a sample. I'm just going to take a sugar cube, maybe, right? We're going to crunch this sugar cube down, and we're going to get like a nice little powder here that I can measure out onto the balance. And then I'm going to put this in solution, and that solution, I'm going to put some of that solid, and I'm going to take it up to the line on a volumetric flask or a piece of glassware, right? I'm going to dilute it down, make a liquid. All right, well, that's great. Okay, well, how do you know if people did this the right way, right? Or from this point on, what goes on after this? Is that it? Or do we have to filter it? Do we have to heat it? Do we have to process it in a certain way? You know, those kinds of things we want to test. So this is going to be the purpose of the surrogate analyte that we are going to add in. So our surrogate is going to be added in to this very initial stage. So after the question mark, when they go through all of these processing steps, okay, the surrogate is getting carried along. How many transfers did you do? Did you lose surrogate? How many filtration steps did you do? Did you lose surrogate? How many times did you have to put it in a new piece of glassware? Did you go above the line? Did you go below the line when you went and did dilutions and stuff, right? Did you add the right amount? 25 mils, 25 mils, 25 mils. You know, what exactly went on in the procedure step? Right? Did you perform the method the proper way or the SOP the proper way? That is the purpose of the surrogate. All right, so here at the very end, what's going to happen is that we have a sample that is now, ding, ding, ready to be processed. So this is getting closer to maybe an instrumentation run. It's getting closer to the end of the method where I don't have to do anything with it anymore. After the method processing has taken place, right before we go to the instrumentation, for the most part, now there's always exceptions, but for the most part, this is where we can now add the internal standard. So we're going to add something else here in the very last stages of a component that is normally not found in there either. And we are prepping this with all of the other things that go on. So standards and samples and quality control checks and everything else that has been processed at this point. Sometimes standards don't have to be processed, but everything has an internal standard that gets added, which means everything should show this peak and everything should have the same number. That is what's going to happen here as far as an internal standard goes. All right. So what we're looking for with the internal standard piece is a signal, and that signal should be the same signal for everything because everything gets the same amount. All right. So there's kind of a diagram or a flow chart really of where a surrogate would take place as well as an internal standard that would take place. Notice that the surrogates, I never mentioned anything about standards, right? This was all about sample processing. That's what the surrogate was. So we're checking the lab method that a person is doing. So if they're prepping standards, it's a standard. That's really all that should be there. But a surrogate is something that gets added into the sample. That's how the definition is defined. But folks, here's the story. If I cannot find this surrogate in my standards, I can't quantify it. So what happens, and it's expected, is that if my job is to go in and apply a number to the surrogate, the thing that I have added in that we're analyzing, that we're going to see, if my job is to cross-reference that and determine like how much is actually there, then I probably need those surrogates in my standards as well. Otherwise, I don't establish a signal against that standard or that surrogate. So the standards are going to have the surrogate in. That way we can do something with the numbers when we build our calibration curve. All right, so that's actually the definition that we're going to talk about next when we come back. It is calibration standards and a calibration curve. Like, what's the purpose? Why do we do one? But this gives us at least 2 or 3 definitions now under our belt of method detection limit, as well as a surrogate, as well as an internal standard. All right, so next video, we're coming back. We're going to talk about calibration curves, and we're going to apply this internal standard and the surrogate into that calibration curve discussion. All right, so come back and see me. I'll be waiting here until you hit play on the next video. Good luck. Bye-bye.